Good morning, and today we're going to be completing the square. Now this is not entirely new. You have done this at National 5, and I will begin by revising what you should already know from National 5, and then I will show you how we take it just a little bit further into a higher level, completing the square question. Now, one of the main reasons that we do complete the square is that it can help us to find the coordinate of the turning point. And you can see here from this diagram that we have a parabola where it doesn't cross the x-axis. And normally, you would find the coordinate of the turning point from the mid-value of the two roots, and then you would be able to find the other part of the coordinate by substituting into the equation that we have. But we can't do that in this case because the graph is actually above the x-axis, or if it was an upside down U, it might be below the x-axis. But completing the square is a method for being able to find the turning point from the answer of the completed square without having to work out the roots first. So it's very useful from that perspective. So completing the square is when we write the quadratic function in this form here. Okay. So we have a bracket squared plus a constant, and that's what you were dealing with at National 5. But at higher, I'm going to show you how we can also have a constant outside the bracket. The axis of symmetry, the x value of where the turning point is, comes from the part inside the bracket. And we say that the axis of symmetry comes from making the bracket equal to 0, and then saying, so in this case, x would be equal to minus p, making the bracket equal to 0. Making the bracket equal to 0 would make this the minimum value. So making the bracket equal to 0 in this case would be x plus p equals 0, so x equals minus p. Now obviously they would normally be numbers, okay? And the turning point is really easy to find, so that's you now found the x value of the turning point, and the minimum value, the y value, is just this value here. So that value there is the y value of the turning point. So you use the bracket, make it equal to 0 to get what x is equal to, and then that just directly gives you the y value. And those are the two parts of the turning point of the parabola. And I'll show you that later on with some numbers as well. Okay, this is just a reminder. It relies on the process, the process relies on the fact that x plus p all squared is equal to, if you square that bracket out, you get x squared, plus you get 2 times the first times the second, 2 times p times the x in alphabetical order, and then plus the last term squared, which is p squared. So we can see this as follows. If we have an x minus 1 squared, that would lead to x squared minus 2x plus 1, x minus 3 squared. Following the same process, the middle terms, 2 times the first times the second, it would be x squared minus 6x plus 9. That would be x squared minus 10x plus 25. Okay, so in the square bracket, the first term is x. So we're looking at it going backwards from here, back to here. So the first term there leads to just an x. And the second term is always half of this coefficient of x. It's half of it because you multiply them together and you double them to get that one. So half of that leads you to the term inside the square bracket. Okay. So let's look at completing the square. So step 1, make sure the equation is in the form y equals ax squared plus bx plus c. So if it's in any other rearrangement, not the x squared, the x and the number in that order, change it around. Make it go into that order. So this one's fine. This is just like a typical National 5 question, so hopefully you'll find this as revision. So we put the bracket round the x squared and the x terms. Okay, so I've actually not really changed it, apart from just adding in those brackets there. Okay, so we're going to write the square bracket. So remember what we have to do. This term leads to the x, and then this term has to be halved. And we drop the x at this point. Okay, so we have an x from that term and a 3 from that term, and that's our square bracket. I've written the plus 5 away over at the end there because I don't want to forget I've got a plus 5 in here. Okay, So now we're going to correct the last number, because if we look at this here, x plus 3 all squared. X plus 3 all squared is actually, when multiplied out, x squared plus 6x, multiply them together and double them, and then the last term is supposed to be the last term squared, which should be a 9. So we have created this term here, an extra x squared plus 6x plus 9. We've created an extra plus 9 in there. So that last term squared has been put in there where it wasn't there to begin with. There was no plus 9 to begin with. So because we have created an extra plus 9, we have to undo that. And we have to do a very simple thing to undo a plus 9. We have to take away 9 to balance it out. So we write the take away 9 just outside the square bracket. Okay, because what we want this always to be equal to is what we started with. Now this was x squared plus 6x plus 5. And if I square this bracket out here, that's x squared plus 6x plus 9. That there leads to x squared plus 6x plus 9. So I have to take away the 9 to balance it out. And I still have my plus 5 because it was in the original question. And then the last thing to do is just collect the constants together. Now negative 9 plus 5 is the same as 5 take away 9, which is a negative 4. That's us got it in the completed square form. So that's exactly what you had to do at National 5 level. Now you might be asked to take it further. You might be asked to show that you have an understanding of what it means. So you might be asked for the coordinate of the turning point and the axis of symmetry. So that's just a reminder of what the completed square form was. So you use the bracket. You use the bracket and you make it equal to 0. So if x plus 3 is equal to 0, that means that x is going to be equal to negative 3. So your bracket must be made equal to 0 to get your coordinate. Now watch out for the bracket having a negative in the first place. Okay, that obviously changes the sign of that there. But you're basically making it equal to 0, which is why the sign of that changes. X plus 3 equals 0. So x is equal to negative 3. The y value is your y coordinate. So x plus 3 equals 0, x is equal to negative 3, and y equals negative 4, and that's your turning point. The axis of symmetry is just the x value, what the x value is equal to, which is x equals negative 3. If you were asked for the minimum value is just the y value, which is negative 4. There, the minimum value comes from there. It's also the end point. Okay. Right, so here's something new. This is higher level completing the square. So what we've done so far was revision. So we're now completing the square for y equals 5x squared minus 40x minus 18. So you'll notice this time we have a number in front of the x squared. That's what makes this different to what we have done before, and that's what makes this a higher level question. So first of all, step 1's the same. Make sure it's in the correct rearrangement. The x squared first, the x, and then the c. It is, that's fine. Then the next one is take out the x squared coefficient, that's the number in front of the x squared, as a factor of the x squared in the x terms. Now the last time I asked you just to put a bracket around the first two terms, and you're still going to be putting a bracket around the first two terms, but you're also taking the number in front of the x squared out as a factor from these two numbers here. Okay, so you're taking that out as a factor. So 5 is going to be a factor of the first two terms. So we divide each of the terms by the 5, so we're left with an x squared and we're left with a negative 8x. So we haven't completed the square yet, we've just factorised the first two terms, but we leave the negative 18 on the end there. Okay, don't touch that just now. Keep it right at the end until you're gathering your coefficients together at the end. Okay, so then the next little part is just pretty much the same. We're going to create our square bracket. So remember, we get it from the bit inside here, and we half that term. So it's really important that you take out your 5 as a factor first, because it's this term we're halving, not the 40, but the negative 8. So that's going to lead to an x, that's going to lead to a negative 4, and then that'll be the bracket with a square around it. So that's x minus 4 all squared. But we still have this 5 outside the bracket, and we still have our negative 18 there. So we're now ready to do the correction of the last number. This is where it's a little bit, you've got to be a little bit more careful. Okay, so let's think what this bracket here is when you square it. X minus 4 squared is x squared minus 8x, but we have a plus 16 that's been created within this square bracket. But remember, we have a 5 outside it. So when we're working out what the correction number is, you work out what the last term squared is, because that's the extra number. And remember, even if it's a negative inside the bracket, that squared gives you a positive, so it's always a positive. But then to get your correction number, you do one very simple thing. You multiply by what's outside the bracket. So we have an extra plus 16 inside this bracket here. But we have to take away 16 to balance it out. But we have to remember that we have a 5 outside the bracket. Remember the coefficient. Okay, so this case it's a 5. So the negative 16 that we know we've created as an extra number, or the correction number, is going to be multiplied by 5. So we created an extra plus 16. We multiply that by 5 and we're going to subtract that number. Okay, so 5 times negative 16 is negative 80, so we're going to subtract 80 there. So it's not just the 16 that we subtract, it's the 16 times the 5 that we subtract. If what you took outside this bracket was a negative number, then you would multiply that number by that, get a negative, and you would end up adding a number on there if that had been a negative. You'll see that when you try some questions. Okay, so the final answer is to collect the constants together, and we have 5 bracket x minus 4 all squared minus 98. Now what would be the turning point of this? This would be the minimum value, that would be your y, and the x we would get from here. So if x minus 4 is equal to 0, the x value would be equal to 4 when y is equal to negative 98. The x value would be equal to 4 when y is equal to 98. So your turning point would be 498. Okay. So there we have 498, negative 98, 4 and negative 98 from that. Your axial symmetry would come from your x equals 4, and your minimum value would be the lowest value in the whole thing. When this whole thing is equal to 0, this would be your lowest value. Okay. Right, so here we have an exercise that we're going to work on to give us a bit of extra practice from the textbook before we get into the textbook exercise. So we'll be working on these questions here, okay, and then we'll get on to the textbook later on. So as always, ask your teacher if you need any help, and good luck and take care.